Good morning, boys. So today we are going to complete the exercise. Some questions were left over in your exercise from chapter 10. So we'll complete those. These are some numericals, very important. I have solved all the numericals. On the right, you can see the questions, and on the left, we are going to solve the answers one by one. Okay. So first of all, let's look at question number 12. It says an object is placed at a distance of 10 centimeter from a convex mirror. Okay, of focal length 15 centimeter. So what is given? We have, first of all, we have to know what kind of problem is this. Is it a mirror problem or lens problem? So it was a mirror problem. What kind of mirror? Convex mirror. Convex mirror means diverging mirror. Concave mirror means converging mirror, right? Converging mirror means what? In which the rays of light actually converge to a point, right? Convex mirror is what? Diverging mirror, in which rays of light diverge from a point or seem to diverge from a point, right? So first we'll write given. We have written object distance u is equal to minus 10 centimeter. Okay. Next is focal length. So focal length is 15 centimeter. After writing this to givens, we have to put the sign conventions. Okay. So we know that for a convex mirror, the focal length is always positive. Why? Because for a convex mirror, the focal length is always, focus is always on the right of the mirror. Understood? So anything on the right is positive, anything on the left is negative, just like our number line, right? So once we have put the given, and object distance is minus 10. Why minus? Because we always place our object on the left, that is on the negative side. Okay. Next, since this is a mirror formula, we will mirror case, so we will use mirror formula. So mirror formula is given by 1 by u plus 1 by v is equal to 1 by f. Okay. So after solving, you please go through the steps. After solving, we get v is equal to, you can see here, v is equal to plus 6 centimeter. So v is what? Image distance. In the question it is given, find the position and nature of the image. What kind of image is this? And also where is the image, right? So v is the image distance. We got the first solution. Next, since v is positive, that is plus, so plus means what? It is on the right, that means it is behind the mirror, and whenever an image is behind the mirror, the image is always virtual and erect, right? Now we can directly say from the positive sign of the image distance that this is a virtual image, right? And virtual image is always erect. Another way of finding here is, I have used, you see, m represents what? Magnification. We will use magnification formula for mirror, that is m is equal to minus of v by u. So we put the values, we get plus 0.6. So I have given you notes in class. If you go through your notes, it's written m is equal to positive. If m is equal to positive, the image is virtual and erect. If m is equal to negative, the image is real and inverted. Hope you understood till here. So you will remember two things, two very important things while solving the problem and the steps. First important thing is, anything on the right of the mirror is positive, on the left of the mirror is negative, right? Second, for convex mirror, focal length is always positive. For concave mirror, the focal length is always negative. Next is, whenever the value of m, that is magnification, is positive, the image is always virtual and erect. Whenever the value of m, that is magnification, is negative, that means the image is always real and inverted. So that's your solution to question number 12. Now let's move to question number 13. So in question number 13, it is given the magnification produced by a plane mirror is plus 1. What is the value of magnification? It is plus 1. So as soon as I see magnification is plus 1, what do I understand? This is virtual and erect, right? Second thing it is given in the question, it is a plane mirror. Understood? So for plane mirror, what does this mean? This means that if I put, see, we have the formula for mirrors, that is m is equal to h dash by h. What is h dash? It is image size. What is h? It is object size, right? And the value of m is 1. So you can see I have put plus 1 is equal to h dash by h, which means h dash is equal to h. That means what? The image size and the object size both are equal, and the value plus 1, that is positive magnification, means that the image is virtual and erect. That's your solution for question number 13. Okay. Now let's move to question number 14. So question number 14, it is given an object 5 centimeter in length is placed at a distance of 20 centimeter. What is the object size? 5 centimeter is placed at a distance of 20 centimeter, right? That is, object distance is 20 centimeter in front of a what mirror? Convex mirror. And radius of curvature, that is C, radius of curvature R, that is from pole to C, is called radius of curvature. It is 30 centimeter. Find the position, that means where is the position of the image, its nature, and the size of the image. So first we will write the given. Here it is, size of the object H is equal to 5 centimeter. We'll write that. Object size U is equal to minus 20 centimeter. Radius of curvature R is equal to 30 centimeter. After writing the given, we will put the sign conventions. So we know anything on the left is negative, anything on the right is positive. Our object is always placed on the left, so object distance will be minus 20. Anything above the principal axis is positive, anything below the principal axis is negative. Size of the object is always placed above the principal axis, so it will be positive, that is H is equal to 5 plus 5 centimeter. Radius of curvature is given 30. So we know for a concave mirror, what is this case? So sorry, this is a convex mirror. For a convex mirror, our radius of curvature and our focal length is always on the right? So that will be plus 30 centimeter. Now we know that in class I have given you focal length is equal to radius of curvature by 2. That means focal length is always half of radius of curvature. Understood? So f is equal to r by 2. We put the values, we get the value of focal length f is equal to 15 centimeter, which is positive. That means to the right side of the mirror. Now again we know, since this is a mirror case, mirror problem, so we'll go by the mirror formula, which says 1 by u plus 1 by v is equal to 1 by f. Okay. Next is, after solving this, we get v is equal to plus 8.57 centimeter. Okay, so if I get the value of v, that is image distance, as positive, that means my image is formed on the right side of the mirror, right? On the right side of the mirror, that is behind the mirror. Okay, so that is a what case? From the previous question number 12, I have told you anything on the right is behind the mirror and it is virtual and erect. Another way of knowing this is what? We will use magnification formula. So we know that m is equal to h dash by h or minus v by u. So by putting the formulas, we get h dash is equal to 2.14, which is positive. That is image size. H dash is what? Image size. Okay, so the first question, the solution to our first question was position of the image. We got v is equal to plus 8 centimeter, 8.57 centimeter. Nature, since it is behind the mirror, virtual and erect. Third is, what is the size of the image? So size of the image h dash is equal to plus 2.514 centimeter. That means it is above the principal axis. Understood till here? I hope it is clear. Okay, next we move to question number 15. Question number 15, you see, it is a what case? It is again a mirror problem. It's given an object of size 7 centimeter is placed at 27 centimeter in front of the concave mirror. What kind of mirror? Concave mirror. Focal length is given 18 centimeter. At what distance from the mirror should a screen be placed so that a sharp focused image can be obtained? Find the size and nature of the image. Understood? So what are the three things that we have to find out? Distance at which the image, a sharp image will be formed, that is image distance. Second is what is the size of the image, and third is what is the nature of the image. Just like the question number 14, same problem. We first, by using mirror formula, we find v is equal to minus 54 centimeter. Now minus 54 centimeter, okay, minus 54 means it is in front of the mirror, that is left of the mirror. So that will be what? That will be a real and inverted image. Now again we go use the magnification formula. M is equal to h dash by h, which is minus v by u. So we put the values, we get h dash is equal to minus 14 centimeter. Understood till here? So negative value of h dash means that the image is below the principal axis, that is image is formed below the principal axis. Understood till here? Question number 14, question number 15, same case, only one is for convex mirror, one is for concave mirror. Please go through these numericals very sincerely. You need to put your attention to the every small details. What are the points that you have to remember? First you write given, then you go through the sign conventions, that you put the signs, then you remember if the image is on the behind the mirror, virtual and erect. If it is in front of the mirror, real and inverted, right? If magnification is positive, it is virtual and erect. If magnification is negative, it is real and inverted. Understood till here? So next we move to question number 16. Power of a lens. P is equal to, it is given, find the focal length of a lens. We have to find focal length of a lens of power minus 2 diopter. D means diopter, which is the SI unit of lens. So power is given, which is minus 2 diopter. You have to find focal length, and then you have to tell what type of lens is this. So we know power is given by P is equal to 1 by F. Here F should be in meters, not centimeters, not kilometers, nothing. F should be in meters. So if I put P is equal to minus 2 and 1 by F, I get, by solving, I get F is equal to minus 0.5 meter, minus 0.5 meter. Now this means the focal length is negative. If my focal length is negative, what did I tell you? It is to the left. And which kind of mirror, which kind of lens has its focal length to the left? It is concave mirror, concave lens. Concave mirror and concave lens both have their focal length as negative because they are on the left. Convex lens and convex mirror both have their focal length to the right, which is positive, right? So last question. A doctor, number 17, a doctor has prescribed a corrective lens of power plus 1.5D. So what is the power of the lens? Plus 1.5 diopter. Find the focal length of the lens. Is the prescribed lens diverging or converging? You have to find the focal length of the lens. Just like question number 16, your power is given, which is positive. You have to find the focal length, and then you have to tell, is the prescribed lens diverging or converging? Is it a converging lens or a diverging lens? Diverging means what? It goes away. The rays are going away from a point. Converging means the rays are going towards a point, right? So we write the given power of a lens P is equal to plus 1.5 D, that is diopter. You have to find focal length. So we all know the formula P is equal to 1 by F. So I put, after putting the value of P is equal to 1 by F, I give 1 by, I get the value F is equal to 0.67 meter. So here F is positive 0.67 meter. So positive indicates what? This is to the right of the mirror, to the right of the lens, sorry, it's a lens, to the right of the lens. And which kind of lens has its focal length to the right? It's a convex lens, that is a converging lens. Okay, so to sum up this numericals and in these problems, the important points would be, we know that for a concave mirror and a concave lens, concave mirror and concave lens, focal length negative. For a convex mirror, convex length, focal length positive. Magnification positive means virtual and erect. Magnification negative means image is real and inverted, right? Another very important points I would like to point out here, two important things, that is convex lens. The power of a convex lens is always positive. The power of a concave lens is always negative. Okay, concave lens is always negative. The power of a convex lens is positive. You see, these my lenses, these are concave lenses. Okay, so these are negative power. Understood? These are converging lenses. These are diverging lenses. Sorry, these are diverging lens. A convex lens is a converging lens, right? So hope you understood till here. What I will do is I will give you the solutions in image format, and this video is for I will upload this video for your better understanding. You can watch them, you can pause them anytime you feel like rewinding. You can rewind and watch them again and again. Okay, and the solutions to these questions I will give them in picture format. Okay, so one important task I would like to give you, since till question number 11 it was already done in your class and chapter 10 has been completed. So please and please, I request every one of you, please note down these solutions and all the questions that I have given earlier in your copies. Okay, maintain proper notes, and also please, during your free time, whenever it's your study time, go through your book, look through the examples in your book. Only the problems in exercise won't help you. You have to go through the solved examples in your book. Okay, please go through them. Okay, Hope you understand, hope you have understood till here. Any doubt will be cleared in the next doubt session. Thank you.